Welcome to the second problem of the day. Yesterday I didn't get to do any problems, so I can do at least two today. Been busy with some other writing. Okay, let's see. So this is a standard problem. So here is a drum, and you find this problem, you see the drums as carnivals, so like you definitely will see some carnival. Okay, so it's rotating. Well, let me set it up. You walk into this drum. There may be a door here, and everybody walks and lines up along the side. And there's a floor here, fine. Now they spin. So you go from 0 to some. They know how fast to get it going, and at that point, this floor it just drops off, but you keep spinning. You keep spinning in this horizontal circle, and everybody's stuck to the sidewall. It's a lot of exciting fun. Done that, so let's see. Now the question is, given this is given, so I'm going to just call it omega 0. Okay, it's given, and you have to find the static friction that should be there, otherwise person is to start to slide. Okay, so let's call this just mu s. Okay, there should be the minimum amount of static friction that you need. So this coefficient I need to figure out. Right, so this is another circle, motion in a circle, and this is uniform. It goes, at this point, it becomes uniform. So this is a uniform circular motion. And if you look at the cm of the person, that's the radius r. And angular velocity is omega, so the linear velocity is on this circle, so it's just going to be on the circle the distance you travel, s theta, s equals to r theta, and take a derivative of both sides. This is fixed because circle, and this is omega, and this is v. So v equals to r omega in a circle. So based on that, so let's so here is my circle. People are going in. Doesn't look like a circle. Pick an instant t, the person is here, so the horizontal is easy to draw. The vertical direction is that way, so the gravity is that way, which is mg, and normal is that way. Normal is not pointed up and down. Okay, normal has to be 90 degree. So if you look at the surface, drum surface is that way, and so its tangent is that way. So it's 90 degrees, so it's towards the center. So normal is pointed towards the center, and the friction would, we're talking about there may be forces of friction. Now, which of the friction will be? Well, friction could be along that direction, along the tangent, or along that direction. These are the directions the friction can be. However, because we have acceleration is that way, So normal is sufficient to cause the acceleration, right? As acceleration is being caused by the normal, then if there's nothing to balance this force, it thing will fall. So that's the logic why the friction has to be that way. So if the friction was not there, there will be acceleration that way too, but there's no acceleration there. So we are looking at this. So it's a three-dimensional situation. So this is the horizontal, and this is the tangent part, and this is the normal. So this is the z-axis, x-axis, y-axis. So nothing happening along the y-axis, things like x-axis and z-axis. So in the x-axis, I get n equals to mv square over r. Along the y-axis, nothing. Along the z-axis, I get, and I want, because of this, I want a maximum maximum static friction minus mg and no friction, no acceleration. So this I can replace with mu s that I have times n. So so this gives me n equals to mg over mu s. I plug in here, and then this should give me the answer I'm looking for. So mg over mu s is equal to mv square r, and excuse me, we were looking for this, so just solve for that. Pretty cool, right? Because it's not so obvious before you start that what's really behind this acceleration is normal force. Okay, so if you remember from these kind of things on a inclined plane, so acceleration is this way, but the normal is 90 degrees. So normal is not responsible for that acceleration, they're 90 degrees. So here normal is appears to be on the side. Okay, it's a force, but it's not really an active force. Here normal is the active force. Normal is the one which is keeping you going in circle. Okay, all right. Just advertisement, please subscribe to this channel. If you like this kind of explanation, definitely hit the like button. What it does is actually gives more distribution to this channel, and more people can benefit from these explanations if this benefits you. All right, take care and see you in the next video. Bye.